Hi, in this video we are going to talk about how to solve systems of nonlinear equations in two variables. First, let's visualize what we're going to be dealing with. As you know, when you solve systems of linear equations, that's two lines that may intersect at one point, and then you're going to have one solution. So what's going to happen, what could potentially happen here? Well, you can have a line and a parabola. Then there's a possibility of that intersecting at two different points. You can have a line and a parabola not ever touching each other. What else could you have? You can have a circle and a line. The circle could be intersected by a line at two distinct points. It could be tangent, and you're only going to have one solution there. You can have a situation when you have a circle and a parabola. In this case, you may have three possible outcomes that are listed here, and also the one where it's not going to touch. There's also a possibility of having a situation when you have a circle like that and a parabola going like this. So there's many different situations. In this case, you can have up to four solutions depending on how it's going to be positioned. Alright, so one thing that you definitely need to understand is when you solve these systems of equations, you have to be very, very careful with how you solve them and make sure you don't lose any of the solutions. Okay, so let's start by doing this. This one says to solve by substitution. So if you want to solve this by substitution, we have this expression that equals y, and we can substitute it right there for y. So what do we have then? We're going to have x plus x squared minus 4 equals 2, right? Looks like we're having we're getting a quadratic equation here, so it's going to be x squared plus x minus 6 equals 0. We can solve it by factoring. X plus 3 times x minus 2 equals 0. So what do we have now? We have x equals negative 3 and we have x equals 2. For each one of those solutions that you got for x, you're going to get its own value of y. So when x equals negative 3, if you substitute it into the second equation here, for example, you're going to get negative 3 squared minus 4, which is going to give us 5. When x equals 2, if you substitute it into this equation again, you're going to get 2 squared minus 4, which gives you 0. So the solutions that we're going to get, we're going to get 2 points. First one is going to be negative 3, 5, and the second point is going to be 2, 0. Okay, so we have two intersection points. Example 2. This one's somewhat of an easier situation because you have y equals one expression, y equals another expression. That means you can set them equal to each other, right? So then you're going to get x squared plus 4x plus 5 equals x squared plus 2x minus 1. You should be able to cancel x squared on both sides. And then it's not a quadratic equation. It is going to be just a linear equation, and it's going to become 2x equals negative 6, which means x equals negative 3, right? So what do we need to do? We need to take this value now and substitute it into one of the equations. Let's say I substitute it into the first one, so y equals negative 3 squared plus 4 times negative 3 plus 5. And that means y equals 9 minus 12 plus 5, and that's going to be 2, right? So y equals 2. And the solution here is going to be just 1 point, negative 3, 2. I do recommend, especially when you're starting with these equations, that you take any solutions that you got and substitute them into both equations, just to make sure that you are going to have a correct answer in both of them, a true statement. Alright, moving on. This example here, so we're solving by substitution. In this case, you will have to solve the second equation by either x or y. It doesn't really matter which one. Let me solve this one for x. So x is going to be y plus 1, correct? And then what we do is we make substitution into the first equation. So that's going to give us y plus 1 squared plus y squared equals 25. It's going to be y squared plus 2y plus 1 plus y squared equals 25. We are getting a quadratic equation. We're going to get 2y squared plus 2y minus 24 equals 0. If we divide everything by 2, just to make our coefficient smaller, not required but very helpful, we are going to get y squared plus y minus 12 equals 0, which now you can solve by factoring. So it is y plus 4 times y minus 3 equals 0. And that's going to give us two values of y. It's going to give us y equals, it's going to give us y equals negative 4. And it's going to give us y equals 3. So for each one of them, we're going to have to find the corresponding value of x. So when y is negative 4, if we use that, so then x is going to be negative 4 plus 1, which gives us negative 3. That gives us a point, negative 3, 4. Be careful, make sure you put x first. Okay, negative 3, negative 3, negative 4, right? And then when y equals 3, so x equals 3 plus 1, and you're going to get 4. So this point is going to be 4, 3. Alright. Next example. So just like with the previous one, it is easier to take this linear equation, the second equation, and solve it for y. So if you solve it for y, it's going to be y equals 2x minus 1. And then we're going to substitute that into first equation. So it's going to be x times 2x minus 1 equals 6, which is going to give us, oh, I'm sorry, yeah, 2x, yeah, we're going to get 2x squared minus x equals 6, which gives us 2x squared minus x minus 6 equals 0. This one is not the most favorite to solve by factoring, but it does factor. It's going to give you 2x plus 3 times x minus 2 equals 0. That's going to give us two values of x. We're going to get x equals negative 3 halves, and we're going to get x equals 2. So take each one of these numbers and substitute that into, I'll substitute them into this equation here. So we're going to get y equals 2 times negative 3 halves minus 1, which gives us, that's negative 3 minus, no, that's negative 4, which gives us point negative 3 halves x first, negative 4. And the second solution that we have is second value of x is x equals 2. Substitute that, y equals 2 times 2 minus 1, which is going to give us 3. So that gives us 0.23. And our solutions here are going to be negative 3 halves of negative 4. And the second is going to be 2, 3. I'm writing in a different form because sometimes they've been very specific. It has to be written like that, and sometimes they're a little bit more flexible. So, alright. Now we're going to talk about solving problems by elimination. So when you solve by elimination, just like with linear systems, you want to eliminate one of the variables. You always look for a way to either add or subtract that will allow you to eliminate your variable. So if you look at this one, we have y and y. So if I do minus here, I will be able to eliminate my y's, and I'm going to be only left with x. So that's going to give me x squared minus 2x, x squared minus 2x, y's cancel, equals 3, which if I put it in its quadratic equation, I'm going to put it in standard form, and I'm going to get this, right? So that gives me x minus 3 times x plus 1 when I factor it. That's going to give me two values of x. So x is going to equal 3 and x is going to equal -1. So I would probably use the second equation, it's easier. So 2 times 3 plus y equals 1. That's going to give us, when you solve it, y equals -5. For this one, 2 times -1 plus y equals 1. And it's going to give us y equals 3. So we have 3, -5 as one solution, and the other one is going to be -1, 3. Alright, that concludes this problem. Alright, this example, so we have x squared plus y squared equals 13, x squared minus y squared equals 5. So what do we have here? If you're familiar with conic sections, the first equation is a circle, the second equation is going to be an ellipse. I'm sorry, not an ellipse, a hyperbola. So there's a possibility of having up to 4 points of intersection. How do we eliminate this? Well, you have x squared plus y squared and x squared minus y squared. You can either add or subtract. Let's just add. This way we'll be able to get rid of y squared. It doesn't really matter which one you do first, you will end up with the same exact solution. So we're going to have 2x squared equals y squared cancel, 13 plus 5 is 18, x squared equals 9. So x is going to equal plus or minus 3, right? But if you go back to the original equations, both of them have x squared. So instead of squaring it back again, I'm going to take 9 and I'm going to substitute x squared with 9. So if I go with the first equation, I'm going to get 9 plus y squared equals 13, which means y squared equals 4, and it means y equals plus or minus 2. Okay, so just to avoid any mistake here, every value from here goes with every value from here. The logic is very simple. If I take, for example, 3, and I substitute this into the first equation like I did, I'm going to get 9 plus y squared equals 13, and for 3 I'm going to get plus or minus 2. And the same thing is going to happen with -3. So the solutions here are going to be a total of 4 points. 3, 2, 3, -2, -3, 2, and -3, -2. Okay. This one is very similar. I would add them together, just like I did the previous problem. This way I will be canceling y squared. So what am I going to get here? I'm going to get 8x squared equals 8, which means x squared equals 1, which means x equals plus or minus 1. So then for each one of those, I'm going to substitute that. But again, if I go back to the original equations, they both have x squared, so it makes sense for me to substitute x squared with 1. So if I go with the first equation, it doesn't matter, you could use the second one. It's going to be 4 times 1 minus y squared equals 4. So, which gives you 4 minus y squared equals 4. It means y squared equals 0, which means y equals 0. So yes, I did get two different values of x, but they both generate the same value of y. So my solutions here are going to be 1, 0, and -1, 0. Correct? So that's this problem. Let's go to the next one. We got this one. So we're solving by elimination, and again we have y squared and y squared here, and the best thing to do in this particular case is subtract these two equations, which will allow you to cancel y squared. So that's going to give us x squared minus x minus 8 squared equals, y squared cancel obviously, 25 minus 41 will give us negative 16. Well, now we have to distribute, well, not distribute, expand this, and please be very careful, there is a minus, so expand this first and take care of the minus, keep it in parentheses until then. X squared minus 16x plus 64 equals negative 16. Now we can distribute this negative 1, x squared minus x squared plus 16x minus 64 equals negative 16. Right, so x squared and x squared are going to end up canceling each other. And what are we going to be left with? Well, left with 16x, and if I add 64 on both sides equals 48. So x equals 3. Right? Now we need to find the value of y. I think the first equation is definitely easier to substitute this into. So let's go ahead and do that. So it's 3 squared plus y squared equals 25. So it's 9 plus y squared equals 25. Y squared equals 16. So y equals plus or minus 4. So one value of x goes with two different values of y. This is actually two circles. Alright, so we're going to get 3, 4, and we're going to get 3, negative 4. Okay. Next problem. So we got y squared minus x equals 4 and x squared plus y squared equals 4 also. So what we're going to do here, we are going to subtract these two equations because this will allow us to eliminate y squared. I know it's not precisely in the same form, but you can make this happen. It's actually pretty easy. So we're going to have y squared minus y squared, which is going to cancel. And then here we're going to have negative x minus x squared equals 4 minus 4 gives us 0. So that means that if I multiply both sides by negative 1, I can rewrite it as x squared plus x equals 0. Right? Which is going to give, if you factor it, it's x times x plus 1 equals 0. This is going to give us two values of x. It's going to give us x equals 0 and also x equals negative 1. Correct? So when x equals 0, let's go ahead and substitute that. Well, I've been using the first equation so far. Let's substitute that into the second equation. So when x equals 0, 0 squared is 0, so 0 plus y squared equals 4. So that means y squared equals 4 and y equals plus or minus 2. X equals negative 1, so negative 1 squared plus y squared equals 4, that's 1, so you get y squared equals 3, and y equals plus or minus square root of 3. So 0 goes with plus or minus 2, and negative 1 goes with plus or minus square root of 3. And now, so we have a total of 4 points, 0, 2, 0, negative 2, negative 1 square root of 3, and finally negative 1 negative square root of 3. Okay, yeah, don't expect all of them to give you nice rational solutions. You may have an irrational value as one of the values. Okay. This problem, so it's telling you to use a method of your choice. Elimination here is not going to work because you don't have anything like this is x squared and this is y squared and this is a completely different expression. So what we're going to do here is we're going to solve our second equation for, let's say, y. So y equals 4 divided by x. And then we're going to substitute that into the first equation. So it's going to be 2x squared plus 4 divided by x squared equals 18, which gives us 2x squared plus 16 over x squared equals 18. And to make this one work better, we are going to multiply everything by x squared to eliminate the fraction. And by the way, we know we can safely multiply by x squared because x cannot equal 0, which would be the problem when we do that. Because if x is 0, this side would give you 0, this side would give you 4. It's not even possible. Okay? So what are we getting? We're getting 2x to the 4th plus 16 equals 18x squared. I'm going to divide everything by 2. So it's x to the 4th plus 8 equals 9x squared. I'm going to rewrite that in standard form. It's actually what we call a biquadratic equation. And I typically use the same approach whenever I do these types of problems. I'm going to say, let me call t x, let me say that x squared is t. So what is it going to do for me? I will be able to rewrite this equation then in quadratic form, because now it's going to be t squared minus 9t plus 8 equals 0. And I can solve this one by factoring. It's going to give me t minus 8 times t minus 1 equals 0. But remember, that's t. We got to go back to x. So when t equals 8, that means x squared equals 8. So that means x equals plus or minus square root of 8, which is plus or minus 2 square root of 2. But going back to the first equation, well, you can actually use the second one. It's probably easier. So when x equals 2 square root of 2, y is going to be 4 divided by 2 square root of 2, which we need to rationalize by multiplying top and the bottom by the square root of 2, right? So that's going to end up giving us square root of 2, right? What's going to happen when you do negative 2 square root of 2? If you do the same math, you're going to find that y equals negative square root of 2. What about t equals 1? And remember, that's only 2 that we got. T equals 1 was another solution we have here. So that means x squared equals 1. That means x equals plus or minus 1, right? So again, we have two values of x. So when x equals 1, y is going to be 4 divided by 1, which is 4. When x equals negative 1, y equals 4 divided by negative 1, which gives you negative 4. So now we got to get all these very carefully put together. So we have 2 square root of 2, square root of 2. Our other point is going to be negative 2 square root of 2, negative square root of 2. Then we're going to have 1, 4. And negative 1, negative 4. Okay. So that's this problem. Moving on. Again, we're solving by a method of our choice. The best thing here would be to solve it by elimination to get rid of x squared. So what we do is we subtract one equation from the other. So x squared is going to cancel. We're going to be left with y minus 2 squared minus negative 2y, so plus 2y equals 4 minus 0 gives us 4. We need to expand this, so y squared minus 4y plus 4 plus 2y equals 4. You can see that the 4's are going to cancel. And our equation is going to end up being y squared minus 2y equals 0. So we solve it by, we can factor out y, gives us y times y minus 2, and that's going to give us y equals 0 or y equals 2, correct? And for each one of those we are going to find corresponding values of x. Let's use the second equation, it is easier. So x squared minus 2y equals 0. So when y equals 0, we get x squared equals 0, which means x equals 0. When y equals 2, we're going to have x squared minus 4 equals 0, which is going to give us x equals plus or minus 2, right? And then what we're getting here is going to be, be careful, we found them in different order. We found y first, x second, so well, here it doesn't matter, it's 0, 0. Here we're going to have 2, 2, and we're also going to have negative 2, 2. So we have a total of 3 points. Alright, now that's a really complicated one in the sense that this has a lot of terms and you want to figure out what you can do to eliminate the same variable, because you can do different things here, but are you going to end up eliminating the same all of x or all of y? We don't know. Let's take a look. If I subtract x squared is going to cancel and x's will cancel, and I'm not going to have any of those left. So let's go with that. So x squared minus x squared is 0. Negative y squared minus y squared is going to give you negative 2y squared. X's cancel. 6x minus negative 6x is plus, I'm sorry, y is going to give us plus 12y. Negative 4 minus 12 is going to give us negative 16 and equals 0. So first of all, what I would do is I would divide everything by negative 2 to get rid of the negative, and everything's even, so we can get rid of those coefficients. So it's going to give you y squared minus 6y plus 8 equals 0. Very nice quadratic equation, factorable. You have y minus 2 times y minus 4 equals 0. And now for each one of those, y equals 2. So now we have to substitute all that into our equation. So we're replacing y, let's use the first equation, by 2. So replacing y with the 2 in the first equation. So we're going to have x squared minus 0 minus 4x plus 0 minus 4 equals 0. Which is going to end up giving you x squared minus 4x minus, hold on a second, what am I forgetting here? Let me make sure. We got y replaced with, we're replacing y with 2. I made a mistake here, hold on a second, I'll fix it. Replacing y with 2, that's going to give us x squared minus 4 minus 4x plus 6 times 2 is 12 minus 4 equals 0. Alright, now we got it. So when you rewrite that, it's going to be x squared, when you simplify everything, minus 4x plus 4 equals 0. That's x minus 2 squared equals 0, which gives you x equals 2. My apologies, I got myself confused. Okay, the other value is going to be y equals 4. So if I take the first equation and replace y with 4, I'm going to get x squared minus 16 minus 4x plus 24 minus 4 equals 0, which is going to give us x squared minus 4x plus 4 equals 0, which is the same equation as this one, gives us x equals 2 as well. So what do we have now? We have 2, 2, and we have 2, 4. Okay. Got one last example. Almost there. Solve by method of your choice. So we're going to have this one. These two have x squared and y squared. This has x and y. So the most logical approach here would be to solve it by substitution. Solve the second equation for x, which is going to be x equals 3y minus 5. And then substitute it into the first equation. So we're going to have 3y minus 5 squared plus y squared minus 25 equals 0. Expand. This is 9y squared minus 30y plus 25 plus y squared minus 25 equals 0. You can see that 25 and 25 are going to cancel. Let's get rid of that. And let's simplify what we have left. So we're going to have 10y squared minus 30y equals 0. If I can factor out 10y, y minus 3 equals 0. So we're going to have y equals 0 or y equals 3. So when y is 0, I would substitute this in here. We're going to get x equals negative 5. This equation here is the easiest one to go with. And when y equals 3, x is going to be 3 times 3 is 9. 9 minus 5 is going to give us 4. And we're going to get, please be careful with the order, x first, negative 5, 0, and 4, 3. Okay. And I hope this was helpful.